Hello, and welcome back to Part 2 of Section 2.3 of Geometry. Let's complete the examples together. Example 1. Identify the hypothesis and conclusion of each conditional statement. We will continue to use the convention of circling the hypothesis and underlining the conclusion. For letter A, if the forecast is rain, then I will take an umbrella. Following the word if is the hypothesis. Then I will take an umbrella. The I will take an umbrella is the conclusion. B. A number is divisible by 10 if its last digit is a 0. Here's our key phrase if, which means its last digit is a 0 is the hypothesis, and the number is divisible by 10 would be the conclusion. Please note that if you were to rewrite these separately, you would want to replace your pronouns with an actual noun. So instead of saying its last digit is a 0, you would write a number's last digit is a 0. Example 2. Write a conditional in if-then form. Identify the hypothesis and conclusion for each conditional statement. Then, write the statement in if-then form. We will continue to use the circling and underlining technique. Example A. A mammal is a warm-blooded animal. There's no if, there's no then. It's just one sentence. But we are talking about two separate things divided by the word is. On one side you have mammal, on the other side you have warm-blooded animal. So we could say that our hypothesis would be that the animal is a mammal, and the conclusion is about being warm-blooded. Think about what you can conclude from what you already know. If you already know it's a mammal, you can conclude it is warm-blooded. So we will write, if an animal is a mammal, then it is warm-blooded. And notice that I have moved the word animal into my hypothesis, and I don't need to repeat it in my conclusion. I like to avoid using extra pronouns where possible. Try to think of a category, such as animal, and a specific in the category, if a category is specific. Example B. A prism with bases that are regular polygons is a regular prism. We'll use is as our divider. Our hypothesis would be bases that are regular polygons, and the conclusion is regularness, all having to do with the prisms in the first place. So now we can write, if a prism, notice we have to replace with the actual verb, if a prism has bases that are regular polygons, then it is a regular prism. Or we could have written, then it is regular. That would also work. Example 3. Truth values of conditionals. Determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. Here we will start by identifying the hypothesis and conclusion of each statement and identify each of those pieces as true or false. This will help us give a justification for why the whole conditional is true or false. So example A, if you divide an integer by another integer, then the result is also an integer. Okay. Divide an integer by another integer. Could that be true? Well, this isn't a false statement. Really, we haven't made enough of a claim to be falsifiable, but this is something that could work. So we'll call that a true statement. Then what happens? Result is an integer. Is that always true? Well, no. The result of division is not always an integer. That is false. So what we have here is a broken promise. We set up that dividing an integer by an integer would be an integer, but we failed to do so. So this whole statement is false, since the hypothesis can be true but the conclusion can be false. If you would like a more specific counterexample, let's look at 3 divided by 5. 3 divided by 5 is 0.6, which is not an integer. Example B. If next month is August, then this month is July. Next month is August is our hypothesis. This month is July is the conclusion. We are currently recording this in September, so neither of these are currently true, but let's take the case of when it is true. When the next month is August, which month comes before August? June, July, August. July comes before August, so this month is July, would be true. So this entire conclusion is true. The conclusion is always true when the hypothesis is true. Example C. If a triangle has 4 sides, then it is concave. Triangle has 4 sides is our hypothesis. Triangles don't have 4 sides. This is outright false. Our conclusion, it is concave, well, could be true or false. I'm not really sure what we're talking about here. It would refer back to triangle, just by rules of English, but that's not really guaranteed. We are currently in fantasy land because we're calling a shape with 4 sides a triangle. Could be concave, could be convex. Either one is possible, neither is guaranteed. But because we started with a false premise, the entire conditional is true, because in Fantasyland, where triangles have 4 sides, anything is possible. So this conditional is true since we started with a false hypothesis no promises are broken by the conclusion, whether it is true or false. You haven't done anything wrong, therefore the whole conditional is true. This is why you must be careful with your hypothesis when making a conditional statement. Finally, example 4, related conditionals. Write the converse, inverse, and contrapositive of the following true statement. Then use the information at the left to determine whether each related conditional is true or false. If a statement is false, find a counterexample. The information at the left here refers to information in the textbook. So let's look at that briefly. For example 4, they're referring to this information. Cats in the genus Panthera include the leopard, jaguar, lion, and tiger. These are the only cats that can roar. They cannot, however, purr. That's interesting. So let's rewrite this statement. Lions are cats that can roar. We're going to use what I've mentioned before, the if a category is specific. Lions are animals, more specifically cats. So we can say if a cat is a lion, then it can roar. And this, as we just read, is true. Lions can roar. But now let's write the inverse. Actually, let's do the inverse in red. To invert a statement, we're going to negate both the hypothesis and the conclusion. If a cat is not a lion, then it can not roar. This is clearly false. For example, or rather, for counterexample, the cat could be a tiger, and tigers can roar. So if you eliminate lion as a possibility, it could be a tiger, but then it can roar. You told me it would not be able to. The promise was broken. Next, the converse. The converse is made by exchanging hypothesis and conclusion. If a cat can roar, then it is a lion. This is also false. And we can use the same counterexample as before. Any cat that can roar could be a lion, but it could also be a tiger again. And finally, let's write the contrapositive. The contrapositive is found by negating and exchanging hypothesis and conclusion. So we will write, if a cat cannot roar, then it is not a lion. And this would be true. Lions are capable of roaring. If you find something that can't roar, it cannot be a lion. Unless, of course, it's a lion with a throat sore. We have written all 4 statements. We have determined whether they are true or false, and we have included our counterexamples. This concludes the example, and this concludes this video. So long, farewell. Enjoy the rest of your day.